A network-centric solution. A network-centric PACS system uses the same infrastructure, protocols, physical mediums, and industry standards that a network architecture employs. Advantages of this are a PACS system that can be fully governed by IT policy, less hardware with no devices that have limited binary addressing, more cost-effective in leveraging network infrastructure and power over Ethernet. Servers can be configured with SNMP for advanced monitoring solutions, as scalable as the network. Real-time decision-making is made in less than 1/100th of a millisecond. No data is stored on edge devices. Some of the challenges in implementing and managing a network-centric solution are it requires an understanding of TCP/IP networking fundamentals, the ability to identify high-risk networks and plan remote servers accordingly, requires an understanding of cybersecurity policies in terms of ports, firewalls, certificates, and VPN solutions. It is only as robust as designed. Things to know before planning the design of your Freedom system. The physical topology of the network. How many switches and routers, and where are they located? How many physical ports are required? Will physical servers be deployed, or will this be a virtual environment? Ensuring the proper logical ports will not be blocked by network components or software appliances, such as firewalls or VPNs. How many site partitions are needed? How will the system be monitored, and from where? How many readers are needed, now and in the future? The exchange of information between the Freedom Bridge and the Freedom Server application is handled by the TCP/IP stack. Understanding the network levels in terms of network communication is important in understanding the requirements of the Freedom system and how it operates. The TCP/IP stack, or the OSI model, defines the transmission of data by layers. Communication that takes place between the bridges and the Freedom server happen at layer 1, 2, and 3. This is a quick review of how information is encapsulated, then passed to the next data layer. Understanding how each layer handles information helps in troubleshooting communication issues. Layer 1 refers to the physical medium upon which the data is transmitted, such as Cat5 or fiber. Layer 2 uses hardware addresses when relaying information. A traditional PACS system would use a binary address. Since the Freedom system is a network-centric solution, at this level, MAC addresses are used. A switch is considered a layer 2 device. Layer 3 is where IP addresses are used. A router or a layer 3 switch capable of routing are considered layer 3 devices. These devices maintain ARP tables that track what MAC addresses are registered to which IP addresses and use this table to properly direct network traffic accordingly. A traditional PACS system would use RS-485 and binary hardware that would limit the number of addresses available. Once this limit was reached, another module is required, usually in 8, 16, or 32 options. Because of the Freedom system architecture and its network-centric design, its only limitation is the scalability of the network. You are also limited to 500 bridges per Freedom instance. A redundant power supply delivery system is essential and should be a part of the business continuity plan. This ensures all network devices are powered up and running. The Freedom system requires a persistent network connection to a Freedom server application at all times. A series of switches is still a layer 2 network. With power, These bridges will not lose connection to the Freedom instance and have multiple path options in the event of a failure outage, in terms of server roles, there is some key terminology to understand. Data hierarchy, master. This refers to the authoritative source, which is the Freedom Server node that contains the database. All changes are made to the master, which in turn pushes any changes out to all its replication nodes. Slave. This is a replication node. These are redundant devices and are populated via the master. A Freedom server can be a master server or a slave replication node. For bridge connections, they look to servers for authentication. They can be programmed to look at 3 different servers: a primary, a secondary, or a tertiary. Servers can behave in any combination of data in bridge role. A router has at least 2 network interface cards in different local area networks, routing traffic between them. Here, it is possible for a site to lose connection to another. However, the bridges will still always be able to reach their local cube. In this topology, the Freedom system is using an existing network infrastructure for its communication. In this example, there are multiple points of redundancy in the case of a network component failure. The only non-redundant point is the switch to which the bridge is connected. Most IT infrastructures will already have this network in place to accommodate the Freedom system.